All right, our next topic, we're going to go back and have a look at arithmetic and geometric series. Now let's just have a look at this question here from a past HSC. Heather is going to try and improve her fitness level. So first day she's going to swim 750 metres. It's not bad for the first day if you're going to start swimming. And each day after that, add another 100 metres. Just in case you didn't realise, they then help us with this question and say, well, that means that on the second day we swim 850, then 950 on the third day, and so on. They want us to find a formula for the distance she swims on the nth day. Well, we know the first term is 750, the common difference is 100, and our general term for an arithmetic, a plus n minus 1d. Subbing that in, but let's tidy it up to get a nice neat formula. 650 plus 100n. All right, how far does she swim on the 10th day? Well, now we just use the formula that we just found. So term n, remember we just found 650 plus 100n, sub in 10, 1,650 metres. Well, if we were to add up all that she swum in the first 10 days, so over the course of 10 days, so in other words, they're asking us, what is the sum to 10? Our sum to n formula. Okay, n on 2, 2a plus n minus 1d, sub in all the values that we now know, and we end up with 12,000. Of course, we could have used the alternative formula, n over 2a plus l, because we just found that on the last day, on that 10th day, she swims 1,650, so subbing in, and of course we get the same answer, 12,000. So after how many days would she have swum the total distance of the English Channel? And the English Channel is 34 kilometres. So again, we need our sum to n formula. We want to know when that sum is 34,000 metres. We're trying to find n. So we'll end up with a quadratic equation. So let's expand everything out, tidy it up, and everything divides by 100. N squared plus 14n minus 680. So it multiplies together to give negative 680, adds together to give 14. So we have our two solutions, n equals negative 34. Well, that doesn't make sense in the context of our question. So n equals 20 is the one we're looking for. So after 20 days, she swum those 34 kilometres. Company sales declining by 6%. So declining by a percentage every year, this one's going to be a geometric. During which year will sales first fall below 20,000? So the first term is 50,000. Our ratio, we're dropping by 6%. So our ratio is 94%, or 0.94. We want to know, when is the general term less than 20,000? Well, our general term is AR to the n minus 1. Let's solve it. 20,000 is going to be greater than 50,000, 0.94, it's the power of n minus 1. We end up with an exponential inequation. So let's make use of our log laws. Log both sides, n minus 1 can come to the front, divide by log 0.94, but remember, a log of a number smaller than 1 is a negative number. So we're actually dividing by a negative number when we divide by log of 0.94. And as we say, when you change the sign, you change the sign. So n minus 1 will be greater than log of 0.4 on log of 0.94. So we eventually get n is greater than 15.8. So when is the first whole number bigger than that? Well, 16. So during this 16th year, the sales will go below 20,000. Let's have a look at another HSC one. So Anne and Kay are employed, but they've got different contracts. Anne's contract is she's going to start with $50,000, and she's just going to accept an increase of $2,500 every year. Kay also starts with $50,000, but her salary increase, she said, well, I'll just take 4% every year. So Anne is an arithmetic. Her first term is 50,000. Her difference is 2.5, whereas K is geometric. Increasing by 4%, so the ratio, 1.04. What's Anne's salary? Well, Anne's salary, Anne was the arithmetic one, so we use our term n is a plus n minus 1d. subbing in for 13, and she ends up with $80,000 in her 13th year. Well, how did K go? Hers is geometric, subbing in, ends up with just a little bit more, $80,051.61. So obviously K is now earning more than Anne each year. So after 20 years, how much more does K actually get than Anne? So the sum for Anne's n on 2, 2a plus n minus 1d. We want the sum of 20. So she ends up with $1,475,000 after 20 years. K, so using a geometric, subbing in, she ends up with $1,488,903.93. So the difference between the two, K's ended up with an extra, well, almost $14,000. This sort of question is basically seeing whether we understand the condition for a limiting sum. And you'll remember that the condition is the ratio has to be in between minus 1 and 1. So we know that only will happen then. Well, let's work out our ratio. It's 1 on the square root of 2 minus 1, which is 2.414. So no, this will not have a limiting sum. Now, also with limiting sums, here's a very interesting question that was put in the 2004 HSC. So we've got 1 minus tan squared plus tan to the power of 4, and so on. Now, depending on what theta is, sometimes it will have a limiting sum, sometimes it won't. So they're saying, well, with those situations where it does have a limiting sum, what would that be? Well, A is 1, our ratio is minus tan squared. So A on 1 minus R, 1 on 1 plus tan squared. 1 plus tan squared is, of course, sec squared. Reciprocal of sec squared, cos squared. Now we're looking at angles in between minus pi and 2 and pi and 2. So when does that limiting sum exist? Once again, we know it's going to be in between minus 1 and 1. So minus tan squared has to be in between minus 1 and 1. Well, multiply everything by minus 1, change the sign, you change the sign. Mind you, in this case, we still end up with the same inequality. So tan squared is also in between minus 1 and 1. Take the square root of both sides, and we get that tan theta is in between minus 1 and 1. Now, tan theta plus or minus 1. Well, that happens when theta is plus or minus pi on 4 or 45 degrees. If I have a look at my graph, so here's my tan curve going between minus pi on 2 and pi on 2. Now, I've just drawn in where theta is pi on 4, or when the answer is 1, whichever way you want to think about it. So we can see that our limiting sum, the curve is below y equals 1, or above y equals minus 1, when the x value there is in between minus pi on 4 and pi on 4. Okay, 14a, 14b, basically just looking at applications of arithmetic and geometric series.